here. Okay, hi everyone. Welcome to the second part of our design review about spatial statistics in Wolfram language. So last time I think we had gotten spatial estimate was our
candidate name.
What's that?
Yeah, our candidate name, spatial estimator, probably, right? You wanted a noun.
Yes, or spatial estimation.
Okay.
But let's just take a look at how that actually works.
Can I bring up another issue? I just want to put it on the table and we can decide. If you go to that guide page.
Of which guide page?
Spatial predict, that's one listed in the design review notebook. Now, if you click, click on.
I click the O button.
Did you? No, I don't. No, you're supposed to get up a form.
Okay, well, let's see it again. Okay, it says open guide page.
No, the other one to the right, the little one, that OR, that one. Now you type in spatial. Yeah, see it?
Oh, this is remarkable. Yes.
Isn't it wonderful?
Okay, which one do I click?
Spatial prediction.
Okay, that was good, Roger. Yes, that's in the airplane cockpit of DocuTools.
Yes,
it's a good
really.
It's a good thing. It's the thing.
Yeah, particularly on the Mac, it's so hard to do. You know, the other way.
Oh,
okay.
I have to remember that. Arguably, we could make that button bigger. Okay, go ahead.
Okay, so here's a question for you. Okay, so data is super important for here. And so we want to leverage the Wolfram data repository.
Mm-hmm.
But, you know, beyond using them in examples, I think it's very important on the guide page to show sort of domains of data. We will seek out and curate data and add to the Wolfram data repository so that we cover many different domains. Now, we need an idiom. I would like an idiom so we can show them on the guide page. I would like to showcase data sets on the guide page.
Right. Well, I mean, so what we've done in other places is things like net model, you know, is its own symbol that is a specialized symbol, which, well, I mean, that's its own repository as well. This is a good question, how to do this.
Okay. I want to do this for not just this function, but for lots of functions. I want to showcase not every data set, but it's sort of a variety so that you can see the application domains. And this gives you a quick start too, because when you go to those pages, we build those pages for Wolfram Data Repository. We will showcase the very same functions and show like micro workflows and so on.
Okay, but the problem is, you know, US ozone data in 2021 is something incredibly specific.
Yeah, but I don't think it, you know, so the thing is that we can gather a variety of such data, and it doesn't matter that it's.
Okay, I've got a different suggestion, Roger.
Okay. Okay.
My suggestion is a page. I don't know what it is exactly. It lives. Essentially it's a guide page for the data repository. Okay, and so what it would be is a page, and we've been talking about this. Actually, you know what? This dovetails with something else that's happening. We are making guide pages for the function repository.
Right. Actually, I was going to bring that up as another proposal as well. If there is a guide page at the repository level that we curate, because then I can point to that and it can be dynamically growing.
I think that's fine, and that's what we're planning. There's nobody here, I think, who knows about that. That's Brady would know about that, but that's something I think it's almost done. I think even for the function repository, I believe that is, if it isn't already deployed, it's about to be deployed.
Right. I think that's good, but I think it's still valuable to be able to point to individual data sets.
Well, why don't you just look? I don't think it's a great idea on this page. I think what you should do is point to the, you know, have a way to point to the guide page, which is then all data, you know, which then has very specific data on it.
Yeah.
Unless you have data. Look, here's the thing. If it's data that is so generic, that is part of the, you know, ozone levels in 2021 or Swiss rainfall, it's just not anything that's sample data isn't generic data, period, end of story, right? If you have, for example, the world's rainfall data, or you have, you know, something like that, then that should be part of our entity system and part of the general knowledge base.
Right. But probably what you're saying now means that we can't solve it for 13.0.
Well, you can solve part of it. Yes, but Roger, what I'm saying is we're breaking it into three pieces.
Mhm.
Okay. One is data sets, which could include some of those, NASA. Oh gosh, what are those things called? Christopher knows about what I'm talking about. What are those? The endless layers of that.
Oh, the
Like,
geo observation satellites, the mission Planet Earth type thing.
Yes,
They have various programs that been run, satellite programs been running on that.
but there's an aggregation of that. What is that?
wait, sorry, you mean the page? There's like four or five different services where NASA tries to consolidate all their satellite data.
Okay, fine.
Yeah.
Okay, but so that's an example, something like that, and the gateway to something like that. That is a generic, if it's like vegetation of the world or something,
Sure.
that's something that is, as far as I'm concerned, that's a general knowledge-based thing. But rainfall in Switzerland is not.
Right. But actually, it's valuable to have specific data sets that can be, I don't know, gold deposit levels in, an area in South Africa.
I understand that. That's a sample data set. Okay.
Exactly.
But that's
valuable.
I know, but I'm saying, don't mix that up with the actual look. There's one level is the function. It's full power function.
So what we used to do is example data, but we're trying to retire example data.
I know we don't want to use that. I don't think it's a good idea. I think
but
this
I
is
need
the right
to be
thing.
able to point to it. Yeah.
Yes, I know. So what I would do is point to a data repository guide page, and you should be able to get that for 13. Those do. It's it should be close enough. You can get one of those. Okay.
Mm-hmm.
I think it will be most likely on the web right now because that's where the data repository stuff lives. But I consider that not unacceptable.
Mm-hmm.
And I think
were you thinking that we would have one in here in documentation too?
Yes.
Oh,
you could. We've built something that makes that possible because
but on one of those guide pages, you need to have pointers to actual data sets, though. Otherwise, it makes no sense, right?
Of course, but those data sets will be on the web, right, in the data repository.
Yes. You eventually go to a page and you get sort of the home page for the data set.
Yeah, right. But I'm saying if you wanted to, you could have the guide page that links to that be an in-product guide page if you care, or it can be also a web guide page.
Right. But that's fine. But then we come back to my problem, which I can sort out with TNewDocs of how to mark that up.
Yeah, I know. Okay, that's a markup problem. They can deal with that.
Yeah.
But I think that's the right solution. I think you can
but then I think that you and I basically had the same idea to begin with. I'm just glad I brought it up. That we're on the
okay, but I think on that page, I would say major data sets, and then there are other ones which are
absolutely
just samples and so on. But I want to make the other point, which is that I've been pushing to get Geo Image and things like that to be able to get, for example, layers of NASA data so that you can have a curated thing where you can say Geo Image of Massachusetts, vegetation.
I see. That would be super interesting. That's the proper curation organization type thing. But part of what we want to do when showcasing kind of solver things like this is to show that it applies to a wide variety of domains.
Well, that's fine, but that's a sample.
Curate,
that's a.
But we can't curate all the domains. We need to show that it applies to all the domains.
But given that you've now got this, spatial statistics stuff, it makes much more sense for us to have these things like georaster of, blah blah blah, vegetation and things.
Yes.
And I mean, so the question is, how do we fork off that process of getting those things curated? Okay.
Yeah.
I think that's something probably to talk to Johan's team about. Okay. Roger, you understand the objective, right?
Well, I think that I'm thinking the driver for curating those kinds of things would be new kinds of data functions in the system, like entities and other query-like things.
No, but what I'm saying is I'm talking about a very specific thing, okay? Mm-hmm. Take the NASA data, for example, these layers, 500 layers of, remote sensing-ish data, mm-hmm. Vegetation level, rainfall level, this, that, and the other, tagging for types of, climate zones, whatever it is, right?
Yeah.
Okay. Each one of those is something that GeoRaster, Geo Image, I'm not sure exactly which, should be able to request.
Oh,
So,
but
so
that
I mean,
means, go on.
go ahead. Sorry.
No, but then I'm saying that that's something that when we develop those functions, that's what those functions would want. GeoRaster, Geo Image.
Yes, I know.
You know, it's like
Right.
a repository for those guys or something.
Well, but there's also right, and some of that could probably be interfaced in with the Geo server, something like the Geo server option for Geo Image already. Although it would have to have more stuff in it. But there's also stuff like I do know that there are some of the standard like NASA data sets are like point distributions, or like what they're called, spatial point data, basically, like where they had things like I don't know, like maps of for example, I know one of them is they have like a map of like where are there fires, and they have a version of it where they just have a point for each fire and then metadata associated with that point. So that would be an example where it's not a raster.
Yeah.
Right. So I think what we need to know, Roger, is beyond samples, right, of the Musi River or whatever, beyond those kinds of samples, are there global data sets that you want to be able to access with the spatial statistics functionality?
Not really. I mean, I don't think
that.
No, we've been exploring sort of what the variety of where you should have data of this form, where data is going to come from, because this is a processing function, right?
Yeah.
And
fine.
But if there's another one that's more like a database, like a data function, then its mission in life is to curate data and have.
I understand that, but so the question that's being asked is this: we already know at the level of rasters, there's tons of data about the Earth, right? Yeah. Already known. Okay, which is worth curating. We just haven't done it yet.
Right.
Okay, for spatial point data, we do not know how much stuff there is that is kind of whole Earth data that's worth curating. That's something we should know. Does that make sense?
We've done some of that, but I don't know either, because I think here's a secondary thing.
Well, let's find out. Right. Yeah.
The secondary thing is that you can often, the question is, can you derive it from other data? Can you process your way
I understand.
To that? Which is, when you're interested in it, that's part of what you're going to try to do. Cheapest way to acquire data.
Yeah, I know, but we have a very specific question here. The question is, in our knowledge base, is there something to support all the work you guys have done on processing functions? Is there something that should be added to the knowledge base? If the answer is no, fine. If the answer is yes, let's determine that now rather than X years from now.
Yeah. Okay. We'll return to it. We've spent some time on it. Some more time need to be spent.
Okay. But it sounds like Christopher knows of at least one database of some kind.
I think we're aware of the NASA database. Maybe we haven't spelunked as deep as Christopher, but
Jose, on our live stream, SS is saying the European Space Agency has Sentinel-3 data apparently, and SL says very few fires in the US are tagged with points. They're usually polygons.
It depends. There are like three different. There are several different sources for the fire data, but yeah.
Okay.
I know. Like, for example, on the source where I don't even know what the standard format is for the point data, but I know like on I think it's called the NASA Earth View, which is one of their more like easier to interface with systems, that they have a bunch of raster layers, and they also have these point layers.
Okay. I mean, there's a thing called Worldview. Okay, so here we go. So this is welcome to Worldview. Okay. So most of these are raster data.
Yeah. No, the main problem with this one though is the fact that the raster data, none of it's like like they don't give you the raw numerical values. They just, like, if you get something like the temperature map, it'll be on a scale from blue to red, right? Which isn't very useful if you want to process it in any way, right? You can't actually get the number for the temperature.
I see. I was wondering whether somewhere on this site they actually have a thing where they've broken down their data sets by what type of data it is.
There is an API behind this site where you can access all that stuff, but it's still
Fair enough.
yeah.
Okay.
And one thing that I noticed a long time ago when I went in looking there, is that they've had funding that goes for a program of satellites.
Yeah.
And they build a website. And then there's another program for another cluster of satellites, and they built their own,
Sure.
website. And so it's kind of like a
Right.
big mess.
Right. Okay. So, okay. Let's keep going here. All right. We were talking about spatial estimator or spatial. So let's walk through. We were talking last time about variograms and
Yes.
all of that stuff.
So variogram, if we want to drill into that today, because that's the sort of the meat and potatoes of this thing.
Okay. Well, but let's go checking this function first. So what the proposal right now will be to call this spatial estimation. Is that a reasonable name? I mean, spatial. Okay, so and remember, what it's eating is either location value or wait a minute, spatial point data. Wait a minute, what annotation of spatial point data is this picking up as values here in this example?
This is where this was coded using spatial point data. And there's one annotation that happens to be continuous, which is the ozone level, apparently.
Okay, so what this is saying is, okay, I don't understand this. Okay, look, guys, point value plot is picking up some value there. Which value is it picking up from data? Down here, we're saying it's the ozone annotation that we're plotting, but what's it plotting here?
Good point.
It is plotting the ozone levels.
Okay, so how did it know to do that?
Yeah. How did it?
Well, that's how the lead to the example says ozone readings over contiguous United States.
I understand that.
And if you
No, you misunderstand, Gosha. Why did point value plot know to pick up that annotation?
Because it's the only annotation.
Ah.
Okay, fine. So in that case, there is no reason you can't feed spatial estimation or spatial estimator or whatever it is, why you can't just feed it spatial point data. Because if point value plot,
we could try. We could try.
Then this other thing could take
it may
it
not
too.
be continuous, but we'll try.
No, I understand that. But my point is this.
Mm.
What does point value plot do if there are three different annotations in spatial point data?
Point value plot is made to illustrate all three. This is like,
what does it do?
Well, if you go to point value plot, it can put a bar chart, for instance, at each point.
It will try to also.
Or it can use a shape.
Colors, colors or shapes for.
Well, color can't do more than one dimension realistically.
Okay, so this is a super function.
Yes,
that's trying to do.
Yeah, it has a whole language, and this is not even as far developed as we intended it.
Okay, so I'm going to make the statement, which
because
you guys are pushing back on, but it's obviously the right answer. That spatial estimation should be the same way. That is, if there's categorical data in spatial estimation, it should try and deal with that. If there's this, it should deal with that. It should also be a super function working the same kind of way that point value plot works.
Okay, but now you're confused again, because Gosha she's abusing the function here. This is for discrete, like cities, okay? You can have a number of annotation for a city. Let's say there's 50 things that you know about a city. Can you summarize those for each city?
I know. I got it, Roger. Okay. I got it, Roger. I got it. This is the same mistake. We got to not make this design mistake again, right? Once you give people a general function, it should do the best it can. I don't care that you've got, a whale is not a fish. Right? You can say all you want, a whale is not a fish, so we can't do this or that thing with a whale. But the whale is a great big, creature flapping around in the ocean. And there's a lot of things that are relevant to whales that are things connected to
Fine,
fish.
We're going to be on spatial statistics longer. It's going to be for 13.1. We're going to deal with categorical data in spatial estimator.
We don't need to.
We're going to have to make the theory.
Not version 1.
We're going to make the theory for it. We're going to build the theory. I don't mind. I like developing theory.
Roger, We don't need to do it for version 1. We don't need
so
to do
version
it.
2 comes for 13.1.
But
So
we
then,
don't need to do it. We don't need to do it yet. We
Uh-huh.
don't need to do it yet. But don't make the whale is not a fish mistake. Right? It's just, you can say, this isn't supported yet. Sorry. Just like we've had things which for 25 years we've said, this is not supported yet. And turns out nobody cares. And when people show up and say, can you please support, factoring multivariate polynomials over extension fields or whatever it is, that's been the design is there, but the implementation is not there. And that's fine. But let's not break the design.
Yeah, I'm not sure this design makes sense for categorical data. Probably.
Okay,
not.
well, let's think it through. Let's think it through. Okay, so, the first point here, it's always disappointing when the simplest example is this long. So let me just understand. I mean, basically, our representation of, I understand this. I understand that representation. We should be able to package it into this. And what we should be able to do is say something like, given that spatial point data, I don't know what the right syntax is here, but, maybe we want just spatial point data arrow, and then the name of the annotation that is. I don't know if
would
that's
be great.
consistent.
That would be consistent. That would be fine.
Is it consistent with other things?
I mean,
something like that.
Yeah, I mean, we do all kinds of things. Like sometimes for an association, we ignore the keys and we take the values.
Right. But okay, so that would deal with this problem. And then what would happen is if spatial point data has only one annotation, then it just takes that. If it doesn't, you qualify it by saying spatial point data arrow, the name of the annotation that you want to use for the values.
That's fine.
Gosha, does that make sense to you?
It does make sense.
Gosha?
Absolutely.
Yes.
Okay. All right. So now let's walk through the rest of what this is doing. Okay. So I wasn't keen on these names, spatial trend model, because that suggests to me, what the heck is a 1 there?
It's
Is that Fortran?
No. This is just, if you go to that page, it considers polynomial models of certain degrees. So this is linear.
Okay. Well, so why isn't it spatial trend order or something?
Because you can have a general model as well.
What is a general model?
The last case. If you have a family that you think that the mountain or whatever it is satisfy, you could fit that.
I see. So what we've done, like for interpolation order, it's just an order, right?
Yeah. Because there's nothing.
Okay, so where do we have this other kind of case where we can have more arbitrary functions as the fitting parameters, fitting things?
Find fit.
And so, but in that case, the arguments.
Yeah. But didn't want to make this a two-stage process where you have to, we want this to be a super function, which means that you can do it sort of in one go. You don't do multiple steps type.
No, I agree. It's just the name of this thing is, what's bothering me is that model is a verb.
What? No. Well, it's both.
I mean, it's not a verb in this case, right?
Yeah.
But it's hard to understand. I also hate seeing things like spatial trend model arrow 1. It reminds me of Fortran. Even though I understand in your case.
I don't know Fortran, so nothing reminds me of Fortran pretty much.
Well, in the IMSL, mathematical function libraries. Okay?
No, I know. I just
you want to do Gaussian quadrature. It's 3.
I see. Okay, well that's not what it is here. It's not.
I know it isn't. It's a meaningful thing.
Right. I mean, it could have, it could be a list of quotes polynomial and then comma order. You know, if
Yeah, I
you want.
understand. I'm not worried about that. I'm worried about the name of the option. That's all I'm worried about.
Okay. Okay.
But you see what I'm worried about. If you just see that name, spatial
Mhm.
trend model,
Yeah,
that suggests to me, oh, I feed it data, it's going to make a model for me.
it will.
No, it won't.
It
This is
will.
not a function. This is
No.
not a function.
No, but
This is
in
an
the
option.
in the processing pipeline, it makes
I
a
don't
model.
care. That name suggests that it is a function that does something. That's what I'm
No.
complaining about.
Well, there might also be the interpretation of model as like a verb. But
That's right. That's what I'm saying.
Right, but
So if we can avoid that,
okay,
then we're in good shape. So how do we avoid that?
Ignored model, just spatial trend.
No, because that again seems like a verb. Find the spatial trend.
But that's what it's doing.
But it's not, Roger. It's an option to a function. It's an
But
option.
it's finding the spatial
It's
trend.
not.
It
it's
is
not. It's
Otherwise, it
specifying
doesn't
what
work.
spatial
And that's
trend.
exactly what the
Roger,
illustration shows.
it's not finding anything. It is specifying what kind of spatial trend you want to be looking for in the data in order to do the fit.
Exactly.
Right?
So
That's what it's doing.
Trend.
Roger, it is not finding anything. It is not find fit. It is an option about what kind of fitting you do.
Yeah, what kind of model to use.
I know, which is an option, not an action function.
Right.
Okay, look, for example, we would have something that says fitting function, right?
Mhm.
Something like that.
Mhm.
That would be a typical name for a thing like this, or nearest function. Nearest function doesn't find the nearest. That's nearest that finds the nearest. Nearest function is a function called within another function that's trying to do something else, that is finding nearests. You see what I'm saying? Did you get it?
I think you're thinking of distance function, but
I am thinking of distance function. Right.
Yeah.
We want a name that is the analog of distance function that represents this is the trend you are trying to use.
Spatial trend function?
If it's a function, that will be just fine.
But you don't want to give the function, then that's a lot of manual work for each user.
Right.
I understand. Eric on our live stream suggests spatial trend method, which I agree is not bad.
No.
Okay, look.
I assume that there's a reason it couldn't just be method. Is there other options that are basically
These shouldn't be methods.
Yeah, they shouldn't be. This is a perfectly prime thing that it's doing. The problem is it's just a naming problem. Okay, let's solve the naming problem rather than pretending it doesn't exist. Okay, if you see this disembodied name, you will get the wrong idea about what it does. That's the problem we have to solve. I mean, spatial trend modeling, but I don't particularly like that either.
that sounds like something that would be true or false.
Yeah, I know.
In
other languages, it would be spatial trend modelization.
What about the spatial trend without the model?
No, because that suggests that it's doing something like a fit.
It is.
You see? No, it's not, Roger. It's an option to a function that does the fit.
True. Yes.
Right? That's what we have to capture in that name.
Okay, can we table it for a sec and then do some others? Maybe we'll come up with naming schemes that more, because there will probably be objections to other names here too.
Well, yeah, let's look at these other names. Where else have we had a similar thing? Well, we have to assume, I mean, in time series, we have a similar thing, don't we? Do you know what I'm saying?
No, we don't particularly.
Yes, we do.
I think
Yes,
it's called
do.
I think it's just interpolation function, or it's something like that. There's stuff like missing value method, which is maybe a bit similar.
Yeah, but they are.
Yeah. Okay, so these ones are all called method.
Yeah, because they're pretty much at that level. They don't have any. Yeah.
Okay, but so
I don't know. They're big method options though. Like, I mean, if you look at, the machine learning functions or like predictor classify, they have massive method options.
Of course. Yes.
Right, but the point Roger is making here is that this thing is a somewhat understandable value that's being given here, somewhat understandable setting. It's not a giant bank switched method-like thing.
No.
That's the point you're making. You're making the point that you could imagine programmatic access to this rather than just bank switching.
Right.
Okay, and that's what so you're trying to capture that in this name, which is fine, except that name is wrong.
Well, but hold on though. I mean, isn't that also the case with the predict methods or the classify methods? I mean, they have their own documentation pages because they're expected to to give it detailed information about what type of model you want. Right?
Okay, but that's the difference. Okay, another name for what we're giving here is, so these are model structures. They basically says what family of models are you considering. Okay, but those methods that you refer to in machine learning, those are separate frameworks that have their own set of options and ways of controlling them. You know, they're dramatically different from each other. And they have basically they're separate frameworks.
Look, it's a little bit verbose, but spatial trend model structure would be fine by me.
That would be fine by me too, because that's what they are. This model families, basically like models with parameters, if you like, you know, and that's kind of what they are. There's just like short names for some of them.
Model family might be nicer than model structure also.
Yeah, model family, model structure is sort of the same.
Well, but is model family arrow 2? Is that, I mean,
well, maybe it should be string polynomial comma 2, and the 2 is just sort of a shorthand for that.
Fine. Well, you can certainly document polynomial comma n.
Yeah, I think we should, because.
Okay, now are these consistent where this thing is? I don't quite understand this. This is a what's the xy here? And this f1, f2, are those pure functions or what?
Those are functions of the x and y.
No, but why is there x and y here at all?
Because those are the coordinates of your points.
But why aren't they appearing in these cases here?
Because those the last one is very flexible. It doesn't give any, you know, it's not restricted to a sort of a fixed class. You know, you can come up with them yourself. You know,
I'm very confused. I would have thought
if you gave, like, say, radial. I mean, actually, now that I think about it, I wonder if they should, you know, that variables probably shouldn't be there. They should just be functions of the points, probably.
I think so.
I think that's the right. Actually, that's a good point, Stephen. Let's get rid of those variables and just have a set of basis functions, basically, that are functions of the points. And so that's still valid. The right-hand side is still valid, you know, it's just the coding of it needs to be differently handled.
So why don't we call this spatial trend function? Because these things can actually just be functions. This thing here could be hash, you know, hash theta ampersand, no, theta ampersand. And this thing here could be, you know, you can easily have, you know, why not just call it spatial trend function? Because it is basically. And allow it to take an arbitrary pure function. This is a list of pure functions.
Yes.
But we'd have to decide how we specify, or the design for how we specify the single integer, which is the kind of shorthand.
No, but that's okay. That's okay. We can still have this notation that says,
yeah, the single integer is fine.
The single integer, or, you know, list polynomial comma integer. That's still fine. That's sort of, this just means those functions, you know.
Right.
There's like, for if you have, you know, let's say degree 2 polynomials in 2 variables, yeah, there's 3 basis functions that are of total degree 2, and you enumerate them.
All right. So what we think we're going towards is spatial trend function, which I like very much. That makes perfect sense. It's in line with our other naming.
Okay.
Right. Let's keep going here. So spatial variogram model. Is that the same story again?
It relates to model variogram, right? So the
which I don't yet understand, but
right.
Hopefully will very soon.
You will.
Okay, but is it the same story where it's a function, or is it the same story where it's a method, or what is it?
It's a function. Okay, so if you scroll down, let's scroll
down.
It's
a variogram function, so we just call it spatial variogram function.
That's the output of model variogram. Yeah. Yeah, I guess it could be that. Oh, But variogram function is the output of model variogram.
Who cares? What's wrong with that? So this thing here becomes, well, that's a bit confusing. So this is spatial variogram. Okay. Spatial variogram function is an option then to spatial estimate.
Right.
And it is also a thing that you could get. Spatial variogram function, it's a little bit confusing what the difference between that and variogram function is.
Yeah.
What is the meaning of the word variogram, really?
It's the expected, it's the go to model variogram. The definition is actually the short. The definition is up here. Okay, it was in the same page.
Okay.
Okay. See there after those pictures.
Yep.
Gamma of 2 points. Okay, and this is the x is sort of a process at those points.
Yep.
What's the variance of the difference between those 2 points?
But what is a gram? I mean, usually when something says it like a histogram, it's a diagram.
No, unfortunately.
What is it?
No, gram was just a popular naming convention in the 50s and 60s. You know, so we have spectrogram, we have.
But a spectrogram is a picture.
Yeah, but the sociogram is like a matrix.
But that's how it started, because it was plotting. So they were plotting this, you know, like these values like that they get from data, and therefore variogram, because they were plotting things to see how this variance changes with the distance between the points. That's what the bin variogram is doing for the data. And therefore the model is also called variogram.
Okay, so hold on. Right now we have a function here called model variogram.
Yeah.
Which produces a picture or produces a function?
A function.
Oh boy, is that confusing. Okay, what does bin variogram do?
But by the way, just for context, I mean, when I go online, look up variogram, there's no plots. It's all descriptions of you know, it's not a visualization,
right,
that pops up.
Grams don't have to be pictures. It's just gram. Everything was supposed to be gram, it seemed to me, in the 50s and 60s. I think we grew out of the gram naming era.
I just thought gram was short for diagram. I thought histogram, spectrogram were all, you know.
I think gram comes from Greek to write.
Yes, well, graph is the that's the root. You know, I have this very convenient book called Composition of Scientific Words. Let me look up gram in that. Let's find out what it is.
Actually, they have the ending in the etymological dictionary or whatever. It says it's from gramma in Greek, that which is drawn or a picture.
Huh.
But it seems that that's kind of, yeah.
That's what I'm trying to tell you, that's historically what people were doing spatial, you know, the Kriging, they were doing this data, and then the way that presenting the computations was to plot that. So it was a plot. It's not a plot. It's now it's a computation, and we have models for that. So yeah, we.
So
look, it's also interesting that a lot of compute methods, you know, going back to, you know, the early 1900s, maybe up to the 60s and so on, were graphical. You know, that was a way to compute in many areas.
Nomograms, for example.
Yeah. And in control engineering, people used basically graphical methods of Fourier transforms and other things to do designs.
Right.
You know, Bode.
Yeah, people have I know. I've
Bode
seen
plots and Nyquist plots. They were, you know, basically design tools from which you did your compute.
Right. Okay, so this is confusing, and it will be really nice if our functions didn't end with variogram, because to the typical average person, it'll be like, that's a plot.
What is does dendrogram, does the output of dendrogram, is that computable, or is it just visualization?
No, it's a plot.
Just a plot.
Okay.
I believe everything we have that is a gram is a plot. We will determine that in 1 second here. Parallelogram. Okay. Special exception for parallelogram. Inverse spectrogram. Well, it's kind of, it's, look, everything else is a plot. Okay, so let's have a think about that. Okay, so let's just first understand what variogram actually does.
Yep.
And okay, I'm sorry, the king function here, I mean, the spatial estimation, what is it going to do? It's going to take spatial estimator. Should it be spatial estimator?
That's what I think.
That returns a spatial estimator function.
Right. That's what I think it should be.
So actually, what's the verb, nounage, whatever for feature extract, feature extractor, feature extraction?
Good point. What is that?
Well, I could tell you what it is. I mean, feature extraction is the thing that returns a feature extractor function.
It's just, it might as well be consistent with this, although at the same time, I do every single time I use these have to look up which one is which.
Yeah, me too. I certainly don't. Yeah.
Well, and then feature extract in this particular case is a rather impoverished function because feature extract is very rarely useful on its own. Right. I mean, that's the thing that. Okay, so feature extract is the one shot I'm going to give you the answer. Feature extraction is the thing that is going to give you a function that you can repeatedly apply. So where does this lie in that space?
The latter.
Okay, let's go through that again, what it's exactly doing. So it's giving you, so it's going to return to you a function
that effectively gives you a continuous value, where there are no point, for every point, even if you only finitely many point values in.
Look, I think spatial estimator is the most obvious name for this because that it is what it is returning to you a spatial estimator. And then it will be a spatial estimator function that is returned.
Mm-hmm. I agree. I like that.
All right. Okay.
Yeah, was there any particular reason? I mean, I also agree, but was there any particular reason why it was feature extraction and a feature extractor function instead of just being a feature extractor and it produces a feature extractor function?
I'm not sure. I
understand your
argument. What's that?
No, maybe it's because there's two of them. I find feature extraction more confusing. Like, it seems like it's like talking about it in an abstract way.
Oh, no. There is also a feature extractor now that I think about it, because that's yet a different thing. That's an option.
Oh my God. Okay.
And in fact, we have to worry about that because, we need to name four things, right? So the concern would be spatial estimator could be. Okay, so here's a question: if you've got a function,
to be perfectly honest, it seems like it should have been the other way around, because you could imagine having an option where you'd say something like feature extraction arrow none or something like that, right? Like the object is a feature extractor.
Feature extractor is very nice. I mean, look at how nicely that goes. Classify. There's the feature extractor that you're going to use.
Right, but I just think that I think it's more natural. Like, I think it's equally natural to say feature extractor or feature extraction right there. But for the usage of feature extraction, it's more natural to call it feature extractor, if that makes sense.
Possibly. I'm not convinced. I really like this usage here. But my question is there anything for which spatial estimator would be the option name we wish we had?
So I think looking forward, I might as well bring this up now. Okay. This is not a can, but it's a beautiful can, but it's a can.
Yeah, it doesn't have, so the worms are really, really elegant.
Yes. So the thing is that, when you do, let's say, list plot or list plot 3D, there is right now the use case we do is interpolation. It will go through the points. Okay, we can still set the order and it will have, you know, it will show phenomena, sometimes ringing phenomena if you have like a third order. But a common use case is that you think your data isn't actually perfect. There might be noise in your data, in which case you don't want the curve that joins them to go through every point.
I think we should have something like fitted list plot that does that.
Right. The problem is that worth having, so think about how many list functions we have.
Yeah,
Okay.
so you're suggesting an something beyond interpolation order that's a fitting, you know, that we call it fitting function or something that represents something that draws the curve independent. Because remember, there's a bunch of other hair inside list plot that, you know, like the thing that draws the points as well as the line and things like that.
Yes.
All of that and all kinds of things. I don't think it's trivial to not go through the points.
We'll come to that. I think it's a heavily requested thing, and it's some of the things that we're sort of missing because we haven't.
Well, I do think that I would like to say that the thing I would really like to have is a trend line, for example, not as a piece of graphics stuff.
So that trend line, or in more generally, trend surface, trend curve, that is what we're talking about.
Okay, fine, but to me then,
but that means that they won't be as wiggly as the ones that we do now.
No, I know that, but what I want to do is to have something where I can get out the trend line, so to speak, and somehow have that be like we have axes that I can just put in a trend line. I can say trend line of data, or I could say trend line of data with 3 points removed or something. So in other words, the trend line becomes like an axis that I can put into a plot, that I can add into a plot.
Interesting idea. But the function that does that is the one that we're designing right now. That will be the one that we use.
Okay, but that's what I would recommend, rather than an incredibly elaborate option cascade for list plot itself. But there's a detail. I mean, we could add a trend line, but then you're going to have all kinds of details about whether it excludes outliers, blah 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 blah, and you know. I think, right. I mean, there's probably a kind of an easy button of just add a trend line to the data that's already there, to all the data that's there. And that's like a grid line type option. And then a different thing, which is a trend line symbolic wrapper that allows you to have much more control.
Yep. All good ideas.
Okay. So anyway, but back to this. I mean,
can I comment on the spatial estimator?
Mm-hmm.
For me, this rings more as an option name. We have process estimator as an option in estimated process. And if we ever want to think about adding spatial processes, then it would be an option.
That was exactly what I was asking for, Gosha. Yep. Yes. Okay, I get it. So I think spatial estimation is what we have to go with.
What I would vote for would be spatial estimate. Not estimation necessarily. I
understand.
But then Stephen will object to the fact that that's a verb and you get a function that actually does it.
Oh, but the spatial estimate.
It's not terrible. It's not terrible, spatial estimation.
Spatial estimation.
I could live with spatial estimate. I mean, in a sense, nearest does this. Well, nearest is none of the above. Nearest is is an adjective, so it's even not at all the same kind of thing. But the spatial estimate. Give me the spatial estimate. I think this would be okay. Spatial estimate.
And then the question: what would be the output? So that would be the spatial
estimator function.
Estimator function.
I think so. Because if you ever have a spatial estimator as an option, one of the things you can feed it is surely one of these spatial estimator functions. Correct? Isn't that right?
Probably. Depends on how we implement it, but yeah.
Right, but the spatial estimator function is fed. Basically, what that is given is an XY pair and or whatever it is. Does this work in any number of dimensions? Yes, it does.
Yeah.
You know, so you give it a you give it a list of coordinate, you give it a coordinate, XY or whatever, and it returns the thing that was the annotation for the point, the estimated annotation for the point at that point. Is that correct?
Yes.
It's kind of weird that it's the, so is it an association? What does it actually return?
Value.
The value.
I'm sorry?
The value.
No, but there isn't a value because there are multiple annotations. Oh, you're feeding it something which has is a singly annotated. That's right.
Yes.
It's a single scalar field.
Yes.
Although in the future, we talked about the vector case, and in the future, it could be an association. And to just feed that through, in the future, all you give it is spatial point data that has an association as the annotation at every point. And then what this does is to make a function that returns for every XY point the association of annotations at that point.
Sure.
Okay, that all makes sense to me. Okay, let's take a look here. All right, so let's go to spatial variogram. Spatial noise variance. Again, that sounds to me like something that computes spatial noise variance. What is that doing? That's assuming a noise variance. Is that correct?
Yes. Yes.
So
the more noisy, if you know something about your sensors, let's say it has a certain resolution or something like that,
yeah,
then you can give it. Okay, that tells us roughly what the noise in the value space is. And that tells you how much you should trust the values.
Right, I understand. So this would be like saying you're going to do a fit, and there are really rounds wrapped around every point of the fit.
Yes.
Do we have a mechanism for doing that? So in other words, for a fit, assume this error bound for every point.
Yeah, we can get out. It's one of the properties that we can get out of that predictor function is the, we can get a rounds out basically, and we can get the variance out for each point.
But the noise variance really controls the discontinuity of the variogram model at the origin.
Okay. Okay.
So what we're talking, it's the rounds at the uncertainty at the end of the result.
Yes,
I get it, but I think I get it. But what I'm saying is, you could imagine something where you're doing a fit, just ordinary data points, no spatial anything, right? Just random data points, right? Mm. And those data points, if we do, and increasingly I hope we will do even more, of fitting, taking into account the fact that there is an error on every point and a round on every point, right?
Yeah.
Okay. So my point is that one could imagine an option, two fitting functions that says, assume this amount of fuzziness for every point.
Mm-hmm.
Okay. We don't, to my knowledge, we do not have that capability right now to assume fuzziness for every point. Is that correct? You can put fuzziness in explicitly by putting in a round for every point.
No, I think, hold on. Does linear model fit? I think that the fitting functions actually do that.
Okay, let's take a look what they do. Those fitting functions could do with a facelift.
Yes, very much so.
I mean, they among other things, they really should use associations.
No.
Okay. So, I mean, what this is.
On the other hand, I'm thinking the variance estimator function, it could be probably given a constant value. I'm guessing. You know?
Right.
So that probably is a way to do it. Yeah. That's
function for estimating the error variance. So,
right.
but that is for every
look
point
at that. Using variance 1, and there's like a bullet, there's a note below. There is a way to give them constant variance. Yeah, there is a way. Because a function is more general than just a constant.
Yeah, here it is. Oh, I see. It's treated as the known uncertainty of measurement. That's exactly the same thing you're doing here.
Right.
So maybe you could just reuse variance estimator function. Got spatial trend function, variance estimator function. Why
Yeah.
not?
Yes, we could.
Okay, fine. All right, let's continue Occaming it down, so to speak. Okay,
Yeah.
let's look at variogram function. Well, no, we want to look at variogram, spatial variogram model. Okay,
Yeah.
so I think I'm going to have to actually understand this now.
Yeah. So model, the thing that contains the meat, and this one points to that, the model variogram page. That one really explains it. This is
wait a minute. This is an option. This is not even what I want.
Right.
What I want is the page that I'm totally confused by. What is it called? Spatial variogram? What is it called?
Model variogram.
Oh, this is just an unbelievably confusing name.
Because it's model based.
Okay, but okay. This idea that we end with variogram is horrible. Horrible. I mean, this is
variogram model.
I think that would be better. Except that then we
But
model
that's
variogram
wrong.
model.
That's
right.
No, I mean, outcome's a function. That is the variogram.
Okay, that's fine. But then, okay, what do you mean that is the variogram? I mean, this is the problem. That used to be a page, a piece of paper that people drew, that then turned into a slang for, for a variogram function. What does the variogram function eat? What are the arguments of the variogram function?
It's a radius. I think it doesn't eat pairs of functions. I think it eats.
It's radius because it's defined for the distances.
If I might say so, could you please give an example here where you just take, this is in the variogram function page, where you just take a variogram function and feed it 7, and it gives you a number, just so we understand roughly what variogram function.
The second example on this page feeds.
It doesn't do that. That's a very. I mean, this is.
The problem is that the way to get variogram function. I need to show you how to get variogram function.
But why don't you just put a variogram function in? So as an example, why don't you just have a variogram function sitting there as input, because you can do that, right?
Okay. Yeah, it can be coming out of the blue. Yeah. Mm-hmm.
I think so. I think it's a good idea. I think it's a good thing to do in general for these functions where it's like, the first question is, what does the animal eat, so to speak? And then we can say, how do you make the animal? You see what I mean? Okay.
Sure.
So what's that?
Chicken and egg problem.
Yes, right. Okay, so in this case, what you're saying is the variogram function returns this thing which I'm about to understand, which is what happens. Okay, what is a variogram? Fits a model to spatial field data and returns this. So this is the variogram for a spatial process is given by the variance. Okay, so you have the random field, you take 2 points, and you're asking,
what's the variance of the difference?
Blah, 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 blah.
So the expected value of their square.
Wait a minute. A variogram function is taking a radius. What you've got here is 2 points.
Yeah.
This is general definition. So in the most generality, yes.
Follow next paragraph. Stephen, follow the next line.
We're working in a stationary case where we have isotropic field. That's where the definition that we're using here is. That's why it works on the radius, in the radial setting.
What is the difference between spatial variance, the concept of spatial variance, and this concept here?
I don't know what spatial variance is.
Well, its obvious meaning would be something like this.
Yeah, but see, that's a scalar thing coming out of there. X of that is a scalar value. So it's a variance.
Sorry, I don't understand. The
X, the field at over a point is a distribution. Okay,
I understand.
So it's a scalar distribution, okay, or random variable, if you like.
Right. At every point in the base space, there is a random variable.
Yes.
And this is asking, what is the variance integrated over for 2 particular points in space? Mm-hmm. What is the variance of the difference between the values for those 2 points.
Yeah.
Right. So for example, if those 2 points were both delta function distributions, fixed values, then this quantity would simply be the difference of the values with a mysterious divided by 2 there.
Yeah.
No, it wouldn't be. No, I'm wrong. It would be 0. The variance will be 0. This is the difference of those distributions, the variance of the difference of those distributions.
Yes.
Okay. Okay, but so now you're saying if it's stationary and isotropic, then this quantity is just characterized by the distance between the points P1 and P2.
Exactly.
Okay. But you are not, in fact, supporting, you can't feed the animal P1, P2. You can only feed the animal R. Is that correct?
That's correct.
Okay, so I don't think this is correctly named.
Mm-hmm.
Because the variogram, as you're saying, is this quantity that
they're
you feed
all called
points
the
to.
variogram.
Great.
Yeah.
Okay, well, let's try and unconfuse people by breaking this apart somehow. Okay, so
Okay,
what this is saying.
Mm-hmm. But just follow it because we have. Okay, that's what you're seeing.
Okay. So I don't understand why this is the white noise variogram. This is the variogram for a white noise distribution, right?
Yeah, when there is.
But I think you shouldn't say variogram there. I think you should say white noise. This case here is white noise, and this is the result for the I would say white noise.
So if you go online and you look up variogram, all you see are these plots. Like as far as I can tell. So my understanding is the variogram, and correct me if I'm wrong, the variogram is basically the function that tells you, like, basically the spatial correlation, is a
Yes.
sort of how correlated 2 points are as a function of distance, right?
Yes.
So for white noise, it doesn't matter what the distance is. There's
Exactly.
no correlation, right?
This is always the same.
Right, but then your documentation here says the variogram, but you're saying in the current slang. So what you're saying is the slang went this way. First, it was a picture, then it was this, again, a field, right? Actually, it's a more complicated object here. This is a field with two coordinates here, and then it degenerated into a pure, correlation as a, essentially radial correlation function.
Right. So the first one is a function of 2 n variables. Then that's simplified to a single variable, right?
Yes. What do you mean 2 n variables? No, the first thing is
the first thing. There's n coordinates for P1, there's n coordinates for P2. So gamma here is a function of 2 n variables in the fully non-isotropic case, and non-stationary, non-isotropic, etc.
Yes, that's correct.
Okay. Now, when it's stationary, it's really a function of the difference. So now it's a function of only n variables. Okay. When it's isotropic, it's now a function of only a single variable. And
it's not a variable. It's a single scalar value.
Yeah.
Radius.
Right.
Right. Okay. So first question: are we always assuming stationarity and isotropy?
Yes.
Right. That's why we have the trend option, because if you have the trend in the field, then overruns your dependencies. So that's why that's important to detrend your data, because only then these models make sense.
Okay, but so what are these doing here? The DAGUM, whatever that is.
So this when you look at the plots, they tell you how this variation is shaping. So when you have 2 points in a distance very close, the value of the field will also change, this much. When you increase the distance, you will see, how soon the variety or the variation will increase. And so you have the steepness, you have the slope, you have the shape, you have the distance.
You're answering a different question. I don't understand. What is this? Where do you put these in?
Well, you can put them in as
you put them into the model here. So you can put model, parameters. So that's the fourth. The one with the fixed parameters. That's the
Wait a minute. So you're saying that model variogram. I love that one called Euclid's hat. Whatever. There was one down there called Euclid's hat. I wonder what they did wear in Alexandria back in those days. Anyway, some kind of, maybe it was some kind of fez type thing. Who knows?
So you can fit this model to your data, or you can explicitly ask for
What the
the
heck
formula.
is Euclid's hat? I'm sorry. Why on earth is this called Euclid's hat? Okay, but in any case, what you're saying is that what you can get out will always be some kind of variogram function, but that
Yes.
variogram function will operate using Euclid's hat or using spherical or using whatever else.
Yes, and the
correct?
parameters. Yes.
Right, I understand, but those parameters will be hidden from you. Those parameters will be ingested as part of the variogram function. They will not be.
No, so there are two ways to look at that. If you have data and you ask for Euclid's hat, it will estimate the parameters from the data. But also, if you want, I know what my ABCs are and I want to work with that, you can also put them directly and get the function with your specific ABC parameters in it.
In variogram function. So in variogram function, you can feed in a Euclid's hat with your particular A, B, and C.
Yes.
Right?
Yes.
I get it. That makes sense. Right. But so this is a way of generating a variogram function. This function, its mission in life is to generate a variogram function.
Yes.
Variogram function.
That's guaranteed to also, so there's a subtlety. You did probably, before that big table of things, there is a subtlety. Stop. Okay. Look here. A variogram function, even one of those isotropic.
I guess it doesn't go through the points.
Yeah. No, but it needs to satisfy these conditions.
It needs to be negative definite. So the whole kind of reason why we have this bunch of models is because when we just compute this binned variogram from data from the binning, what we get, we can say we have some function directly from data. That function is not guaranteed to satisfy this condition that that this proper model must, in order for all this spatial estimation kriging to actually make sense. And therefore, we don't just use directly what we get from data, but we feed what we get from data. So the bin variogram, then we use this to feed the models, which are kind of, on a whitelist. So they're the good models that satisfy the condition. And then this is then fed into the spatial estimation, to give you the values in the field.
Okay. Let's walk through this again. Okay. Variogram function seems like a perfectly good name that can be then used in. Wait a minute.
In spatial predict. So that could be.
That's fed. Crazy. That's crazy. I'm sorry. We're going to end up with a name, spatial variogram model. That's absolutely crazy, right? So we have a variogram function. Oh my gosh, let me think about this for a second. The variogram function returns, again, variogram function is fed what again? What does it eat?
So
the whole data.
The variogram function eats distances. So that's your.
Okay, fine. So it's simply a parameterization. It's going to be, in a first approximation, a Euclid hat with particular A, B, and C.
Yes.
Yeah.
Okay.
Yes. And this is what you can say, specify that I want to use that as my variogram model, the spatial variogram model, which is going to be fed to the spatial estimate.
I get it. Okay, so let's walk through okay, so then in spatial estimate, it will be calling, if you don't give it a spatial variogram model, it will call this horribly named function, model variogram,
underneath, yes,
to get the variogram function that it should be using. By variogram function, what we essentially mean is a radial correlation function-ish thing, right? That's what it is. It's just some radial function.
Yes.
Okay. So let's walk through what these things actually are. So variogram function, boy. Okay, this option to spatial estimate is the variogram function to assume for processing that data, correct?
Yes, correct.
Okay.
Right.
Now, meanwhile, there are some named variogram functions, which are some of the things that you could have used here. And presumably, if we said, and I don't even understand what the word spatial variogram is, isn't a variogram already a spatial kind of creature? What is a variogram when it's not doing this thing with a spatial value field?
I don't know.
We chose spatial just because it like grounds the function in kind of like
I get it, but if a variogram can't be used for anything else, it's like saying, what's a good example? Hexadecimal base. No, that's a bad example, but something where you repeat the name again, so to speak. If variogram means a spatial statistic,
I mean, the other thing to remember is that all these options, I think, are for connoisseurs. I think
I realize that.
The key use case is when you specify no option.
I realize all of that, but you're not going to convince me that we shouldn't do a good job of naming them.
Okay. No,
but the point is they can be named quite.
This is the
quite
definition
long
of
names.
good that are tricky.
Right. Okay. So let's walk through this again. What we've got is something which is the parameterized, all these different named variogram functions. Right. That's one thing. Is we've got to represent the named variogram thing. Okay. It's just a function that is, it's a function of a variable. It's just it's an f of r. Yeah. That's all it is.
Yes, yeah. But it also does estimation.
Yeah. No, it doesn't.
Yes,
no, it doesn't. No, it doesn't. This function does. Model variogram does. Yes. But variogram function does not. Variogram function.
No, it's already estimated at that.
Right. Yeah. Variogram function is just a Euclid hat or something else. Right. So where else in the system do we have something where it is? I mean, these are essentially special functions of the variogrammic world.
Right. But we thought that you don't want 20 new functions.
No, we don't. Right, we don't. So the question is where
we could have the Wendland variogram.
No. Roger. Where in the system do we have something where you have a block? I mean, it's like NetModel, right? NetModel has a bunch of named models, right? But it is all in the NetModel thing. So I would have thought that, okay, so actually I've got an idea here. Okay, so my claim is variogram model should take in it pentaspherical Euclid hat or whatever it is, right? This should be the thing that variogram model, I claim, could be the thing that, let's see, this is the thing that eats R and returns a number, possibly.
Yes.
Okay. Then we've got the thing that estimates. So what I would say is that why not call it variogram model estimate? Because that takes data and returns a variogram model.
Okay.
Then that's the right name for it, is estimate, because what it's doing is similar to a fitting function, right? Mm-hmm. It's returning, this is like fit. It happens to be a fit of the ABCs here in a Euclid hat, as opposed to a polynomial fit or something like that, but it's basically a fit.
Right. Okay. In the other language, it's estimated variogram model. In the language of distributions and processes.
But which one is, okay, so this will be estimated variogram model, that one there.
No, that's not estimated because you don't give a data here, so it doesn't make sense. This is just a model that we don't want to introduce the new symbol. So
okay, all right, okay. Well, so I don't know whether this is estimated variogram model. That would be fine by me.
That's the question now: which way the estimate goes, in front or on the end? Here.
Well, okay. If this is consistent with the rest of the statistics thing, that'll be okay with me. Then we've got one more thing to name, if I'm not mistaken, which is the option in spatial estimate. Right?
There are two. So, but we're still keeping variogram function. right? That
No,
we're gonna...
that becomes variogram model. That's what variogram function is. Variogram model. That's the thing that has a Euclid hat and eats radii. Right? Because that's the special function, right? It's a variogram model that's a Euclid hat model that eats 7.4 radius type stuff, right?
Okay, it's just that the way that we have the variogram function right now, when it's obtained through fitting, it has additional information in it.
Oh, great. We can put additional information here. That's fine. Put all kinds of additional information there. But fundamentally, this is a variogram model that, if I'm not mistaken...
It can be both a constructor and an output, Gosha.
Yes.
It's a little tricky, but we can do it.
Well, I mean, do you think that's the right way to do that?
We've had functions that the constructor... I think I'm going to vote against having the same name for the constructor. But okay. Yeah, that's my personal vote.
Well, by the way, we have only another 5 minutes here, and then we have to wrap this.
So noise is the last one to look at then. The noise.
Boy, Nick is commenting, is temporal variogram a thing?
Yes.
So there is a notion of spatial variogram. Should this be called spatial variogram? Should the whole branding of these variograms be spatial variogram?
And we used spatial to brand the whole set of
I know,
things.
but this isn't called spatial. We're proposing variogram model, and maybe that should be spatial variogram model.
So on my very superficial Googling of variograms, everything I find defines them as being about spatial correlation.
I think, but just as, so the two ways to do it, either have covariation, and there are sort of three variants of that, correlation.
Guys, we're running out of time.
Okay.
The proposal would be, this is the special function that eats radii. Okay. Then we've got, how do you get one of those from data, right? I personally think variogram model estimate would be the more consistent thing, but maybe this is the better thing. Okay, we've got a third case, if I understand correctly. Only one more case. And the case would be the option here, which I think, and maybe that was what Gosha was saying, should be called variogram function. That's the option. See what I'm saying? Variogram function can take a variogram model, or it can take a variogram model estimate. Actually, maybe it's most consistent to call it estimated variogram model. I agree. Take variogram function, arrow estimated variogram model. The default would be that variogram function is estimated variogram model of the original data. Right?
That's what it is now, yeah.
Okay, so the walk through this again, because there's changing a bunch of things, okay? Variogram function is the option. Do you agree?
Fine.
Okay. Variogram model is the special function. An estimated variogram model is the thing that returns the special function from data.
Okay.
Okay. Marco asks, do we have the capability to import WMS tiles? Who knows what WMS tiles are?
Yes, we do have in GeoServer WMS and WMTS, which is a tiled version of WMS.
Okay, and does that dovetail with the spatial statistics stuff properly or not?
No, I think it's just a method, a connection method, a protocol method in GeoServer.
Okay, so the one further function I haven't seen yet is binned variogram. What is binned variogram?
That's the data version of variogram. So the point is that when you look at the definition of the variogram, it was for was looking at the variance between the values of the field among 2 points.
So that's probably binned variogram model.
That's never happens in real life. So you look at all the points within certain distance, and then you average.
We got to have a name here. Is that binned variogram model, or is it something different?
No, because it's not a model. That's not a model. That's
exactly. It's model free.
Yeah, it's just it's gonna give you the data. So it gives you the basically it gives you the weighted data, but it gives you the points at the distances and then the average of these variances at this distance.
Okay, but it's returning. It's another animal that eats. Okay, so it's got the data, but then it returns something which just eats a radius. Is that correct?
No, it does not. It does not eat. It returns weighted data. So the weighted data gives you the points, the data from the weighted data. It's something that you create a list plot with, and the weights gives you the number of pairs that each of this value was obtained.
We have to wrap up here. So
how valid your value is for the variance.
I'm supposed to do another live stream, so we have to wrap up here, and I'm afraid we're going to need another half hour on this thing. Okay. So good stuff. Very interesting. And for folks who are interested, there is another live stream about business and innovation coming up, which is, I really should go on with this, but we've scheduled that. And I'm also being told I should remind people that you can sign up now for our technology conference, which is coming up in, gosh, very soon, like a month, less than a month. Wow, that's coming up quickly. Wow, we got lots of stuff to get ready for that. Anyway, people can sign up for that and have a chance to have actual interactive discussions with everybody here and others. So encouraged to sign up for that. All right, have to wrap up here, and we'll continue this for another half hour